In this video, we'll be proving that the floor of 2x is equal to the floor of x plus the floor of x plus 1/2. In order to prove this, we have to consider two cases. The first case, we're going to say x is equal to n plus epsilon, where epsilon is between 0 and 1/2, and n is an integer, and x is a real number. So if we look at the left side of the equation, we have 2x, which if x is n plus epsilon, then 2x is 2n plus 2 epsilon. And because epsilon is going to be less than 1/2, 2 epsilon is less than 1. So then 2n plus 2 epsilon will be less than 2n plus 1. And so the floor of 2x has to be 2n. And now the floor of x is obviously going to equal n, since it's greater than n but less than n plus 1. Now n plus epsilon plus 1/2 is going to be less than n plus 1, since epsilon is less than 1/2, and when you add 1/2 to that, it's going to be less than 1. And so the floor of x plus 1/2 has to equal n. Thus, the left side of the equation is 2n, the floor of x is n, the floor of x plus 1/2 is also n plus n is equal to 2n. And so the two sides are equal. Now for case 2, we're going to assume that epsilon is between 1/2 and 1. So then 2x is again 2n plus 2 epsilon. But because epsilon is greater than or equal to 1/2, 2 epsilon is greater than or equal to 1. And so we have 2n plus 2 epsilon is greater than or equal to 2n plus 1. And so the floor of 2x has to be 2n plus 1. Now the floor of x is still n, since it's greater than n but less than n plus 1. And now n plus epsilon plus 1/2 is greater than or equal to n plus 1, since epsilon is greater than or equal to 1/2, and also less than 1. So the floor of x plus 1/2 has to equal n plus 1. And now the left side of the equation here, floor of 2x is equal to 2n plus 1. The floor of x is equal to n, and the floor of x plus 1/2 is n plus 1. And so the right side is also equal to 2n plus 1.